Hello everyone. So I was going to do something else in which you can light those LED light bulbs that now we use in the house. I was going to do I call this an inverter. Basically with 1.5 volt you can light up one of those light bulbs for a very nice period of time, and so I just decided to show you that, and how there's also more guys on YouTube, more people that have done this. There's many names for this, but for me, what this is basically an inverter and an oscillating, simple oscillating circuit. So I just have some like 30 gauge wire, an AIM wire. It's the one with the varnish coating on it. I just had a little piece of wood. This is balsa, but it doesn't matter. It can be plastic, it can be cart or whatever. But all you have to do is just put. This is more or less, I don't know, like 7 or 8 centimeters of length. So around this, I have 1, 2, 3 centimeters, so 6 centimeters. This core. This ferrite core or ring, it's like 1 centimeter on each side and probably half centimeter on each externally and outside, so that makes like 3 centimeters more or less of diameter of length of perimeter. So that is more or less what I have here, 6-7 centimeters. 1, 2, 3, 4, 5, so yeah, around 7. So I know that each turn that I do here is around 2 turns here. So I have around I think it is 300 turns here. So that makes 600 something turns. I'm going to try to make around 650 turns on this ring here. So all I did was just make some cuts on the wood and wrap the wire around. So I can easily fit inside this ring, and yeah, that's it. So it's always going outside, inside, out, from the outside to the inside out. And so I'm gonna wrap all this ring, and then I'll show you guys what else you have to do, because basically I'm gonna show you here. So let's see how this works. Since it is an oscillating circuit, what basically you need is a ring, ferrite ring, which the wire will come here, and it will just, let's imagine these are the first 600 turns, and it comes out. This will be your AC out. Your AC out will be here. Then you need to wrap with a can be a 23 AWG wire. You can wrap around 50 turns here. Let's imagine these are the 50 turn, and another one with, you are, and another with 50 turns on the same gauge. So there will be 50 turns, and here 50 turns. Then what we have is a diode. Comes like this. The diode will come from this part of the 50 turn coil, and it goes out, which will be your positive input. There you are. This diode will go to a transistor. This will be like that, to the base of the transistor, So then what we have, this one here will go to the collector of the transistor, the first one from this coil, and the second one you can just go over this is into the first one here. So this rings, it means that it's not touching these two wires, so it just comes out and goes to the positive input. So it will come into this coil, and the power will just come to the base through this can be a germanium diode. Yeah, some 7 volt diode. It can be a, I don't know, a 0A90 for example. It can be that one. The emitter will be straight to your straight to your negative input. That will be your negative or your ground. Where else do we have? And yeah, basically the circuit it's completed. So what does this do? This is you put a continuous voltage in here. It goes inside this coil, and it goes also to this coil. And whatever the voltage is, since this one comes through the diode only in this direction, it will go to the base of this transistor. So when the voltage opens the gate here, opens the base of the transistor, it will allow the negative voltage to go to this one here, right? So when this one is with voltage here, it comes out and goes to here, so that amplifies it, which it goes again to here, and it gets higher and higher. So it will turn this transistor on and off. Sorry if I don't explain this very well, but you more or less know what I mean. So these two coils, basically what they are doing is oscillating between each other faster and faster until they reach a point. And this one, what basically will be is this coil here. It's the high voltage or the higher voltage and frequency that it will put out. And this is what you will connect to your bulb at home, the one with the LEDs here. So let's suppose these are the LEDs inside that light bulb, and this is where you will connect one here on the bottom and one here on the side. So something else? No, I think this is all. You can put from the input voltage on this can be from probably 1 volt to 2 volts or 2.5 volts or half a volt. It's very low voltage. One small 1.5 volt battery will be enough, and the output of this will be around 1 watt to 2.5 or 1.5, 3 watts more or less, which is enough for one of these light bulbs here. And yeah, it's more or less the circuit. So the transistor, you can use PNP. Well, you should use a PNP transistor. It can be a 2N2222, something similar. That's what you will need, and we're gonna start wrapping a little bit. I already have like 80 turns here, so there's only 500 something to go. This is the more boring part, so all you have to do is just go around and start wrapping this wire, which is what I'm going to do now. You guys have to be patient on this part, and just do wherever it's needed, like in everything in your life. You just have to keep doing until it's done. So I'm gonna wrap all this for a while, and you guys wait and see. So let's do it. So, okay, here we are. We've done the Ferrite ring with 650 turns. I might have between 650 700 turns here. So this one is done, and what we're gonna do now is just wrap the other two coils of 50 turns each of the 23 AWG wire. So let's do that now. Okay. So we just do like this. Okay, so there we are. We have one coil with 50 and another one with 50 and one with around 650 turns. This is the 2023 AWG wire, or 23 gauge gauge wire, and another one with the 23 gauge wire. So let me see if you guys can more or less see this. Yep, this is what you get. You wrap all around this here and the other, it's all the same. So here is one coil, two coils, and three coils. So now let's go to make the circuit. Okay, so I have completed the circuit of this exciter, more or less. I only have here on this side the 2N2222 transistor. I didn't find a germanium diode anywhere, so I just used a regular diode, 1N 4007, I think. And the thin wire, it's the one with 600 turns, it's the alternating current, goes to the lamp, the LED lamp. And this is the positive and this is the negative, which the negative goes to the emitter of the transistor, the diode goes to the base, and the collector, it's the one that goes to one of the 50 turn coil, and then it gets out and it goes to the positive of the input. So yeah, this is the circuit. I'm going just to show you this thing working. This is 1.5 volt battery. It doesn't have much power now. It's not much of power because I used a little bit, but I'll show you at least that it works, and so you guys can see it. So with this you can have light. You can hear the transistor. So there you are. I don't know if you guys can see well. Yeah. This is the light that it puts out. It's enough for as an emergency light. So probably can hear it. I don't know if you can hear it, but it's just making the normal noise. And this is how you can light up. So normally you have those garden lights that charge with solar panels. You can use one system like this to charge a 1.5 volt battery, or two of them. And normally those LEDs, they don't put out much light, but with this LED lights, you can put more light out of it. So I will put a new battery on this and arrange this a little bit with the wiring and all that, because this is a little bit loose, so it doesn't break. And I'm gonna put one battery like this and see how long does it take to fully uncharge the battery. So I hope you guys enjoyed. It's a simple circuit, and yeah, it does work. There's no special trick on this, and it's just an amplifier circuit. It works like an inverter. You just put 1.5 volts and it amplifies the voltage. So yeah, it's working, guys. I hope you guys enjoyed, and take care. Subscribe.